Hello students. So let's start the chapter light, and in this lecture 3 we will study the mirrors. Okay. So mirrors, actually this you know that or daily you are just seeing your face on mirrors, and whenever you are going to outside, before that you have to dress up. So at that time you are using the mirrors, and also we are using the mirrors for different purposes, that here we will discuss all these things. Okay. So here first thing, that is the mirrors. So before going to that, let's recapitulate a little bit thing. So according to the recapitulation, first we can see that difference between the regular and irregular. Let me take the pointer. Regular and irregular reflection. So regular reflection, what we have said, there is a smooth surface here, and if this is the incident light and this is the reflected light, and this is another incident light, and this is the reflected light, and all the reflected rays, these are parallel. If all the incident rays are parallel, then all the reflected rays are parallel. So this was called regular reflection. And irregular, so here you have the rough surface, and you can see that this will be like this. So these are not parallel. So that means irregular reflection, here it is the reflected rays, these are not parallel. If the incident rays are parallel, instead of that you can see that the reflected rays, these are not parallel. Okay. So this is the irregular reflection or diffuse reflection. So regular reflection, it occurs when all the reflected rays from a given smooth surface are parallel to the parallel of incident rays. Okay. Sorry. So here, so that means if all the incident rays are parallel, then if all the reflected rays will be parallel. For irregular reflection, it occurs when for a given set of parallel incident rays, reflected rays do not remain parallel to each other. Okay. And regular reflection, this occurs from smooth surface like a mirror, silver spoon like this. And irregular reflection, wood, table, door, book, these are the example. Okay, rough surface example. The image is formed and can be seen in case of regular reflection, but in case of irregular reflection, it helps to see the object. No images or blurry images can be seen here. Okay. So this is the difference between regular reflection and irregular reflection, and this is very important for your final examination. Fine. So please note down this one. So now we'll recapitulate till now whatever we have studied. So let's change the ink color first. When is the diffraction of light is not possible? Here, when the light is perpendicular to the boundary, the diffraction of light is not possible. So when the incident light is perpendicular to the boundary, refraction of light is not possible. At that time, there will be total internal reflection. Okay. Now, what is the difference between reflection and refraction in light? So, reflection of light is when the light bounces off a medium. So, reflection of light is when the light bounces of a medium, and if the medium has a smooth surface, then the angle of incidence is equal to the angle of reflection, and refraction of light is the change in the direction of light as it passes from one medium to another. Okay. Next, state the example of refraction of light. We have a lot of refraction, but the main example is the rainbow. So an example of refraction is rainbow. The light rays bend as they enter okay, so let me delete this thing. Let me change the ink color. So the light rays bend as they enter water drops in the atmosphere, forming a rainbow. Okay. Next, define light. Light is a form of energy that enables us to see things. Light starts from a source and bounces off objects which are perceived by our eyes, and our brain processes this signal, which eventually enables us to see. Okay. Give a daily life example of refraction of light. So the best example is the twinkling. So twinkling of stars and the formation of rainbow. Okay. What is refractive index? The refractive index is the measure. The refractive index is the measure of the bending of light ray when it passes from one medium to another, and it can also be defined as the ratio of the velocity of light ray in an vacuum to the velocity, in a vacuum to the velocity, just a minute, to the velocity of light in a substance or medium. Okay, and n equals to c by v, where n is the refractive index, c is the velocity of light in vacuum, that equals to 3 into 10 to the power 8 meter per second, and v is the velocity of light in medium. Okay, this medium may be air or water, anything. Now, what is dispersion of light? When white light is passed through a glass prism, it splits into the spectrum of colors in order to violet, indigo, blue, green, yellow, orange, and red, and this process of white light splitting into its constituent colors is defined as dispersion. Okay, what is reflection of light? When a ray of light approaches a smooth surface and the light ray bounces back is called the reflection of light. The incident light ray that falls on the surface is reflected off the surface. The ray that bounces back, the ray that bounces back is called the reflected ray. Reflected ray. Okay. So here you can draw this. This is the smooth surface, incident ray, and this is the reflected ray. So this is reflected ray. This one is the incident ray. This is the smooth surface. Okay. Next, what are the types of reflection? What are the types of reflection? First one is the diffused reflection, and there is another reflection, that is regular reflection. Define optics. Optics is the branch of physics which is concerned with light. Okay, it is related to the light and its behavioral pattern and properties. What is wave optics in physics? Wave optics is the branch of optics that studies the diffraction, interference, polarization, and other phenomena for which the ray approximation of geometric optics is not, just a minute, is not valid. What is the total internal reflection? So here the phenomenon which occurs when the light rays travel from a more optically denser medium to a less optically denser medium is known as total internal reflection. And here the complete reflection of a ray of light within a medium such as water or glass from the surrounding surfaces back into the medium. Here you can draw the diagram. So here the complete reflection of the ray of light within a medium such as water or glass from the surrounding surfaces back into the water. That means suppose this is the water. Okay. And this ray is coming to the air. So it will refract, it will refract like this. Okay. Now, another possibility is there. Suppose this is incident to this one, and then it is coming back to the water again. It is coming back to the water again. So this is the total internal reflection. This phenomenon is the total internal reflection. Total internal reflection. Okay. So this is the total internal reflection. And this phenomena here, angle of incidence greater than a certain limiting angle, that is called critical angle. Total internal reflection takes place at the boundary between two transparent medium when a ray of light in a medium of higher index of reflection approaches the other medium at an angle of incidence greater than the critical angle. For water and air surface, the critical angle is critical angle for this case, water and air. So that is 48.5 degree. This is for water and air surface. For water and air surface. Okay. Next, Snell's law. For light of a given color and given set of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. Okay. Why is used Snell's law? Snell's law is particularly important for optical technologies like fiber optics. Okay. What is the angle of refraction? The angle of, sorry, just a minute. The angle formed by a refracted ray and its normal drawn at its point of incidence with a refracting interference. Okay. What causes the refraction? So refraction is caused. These questions may come in your examination, so please be prepared these questions and go through thoroughly these questions. Okay. So it's caused due to the change in speed of light when it enters from one medium to another. Okay. Next question, what factors affect the refraction? First one is the temperature. Second one is the wavelength. Okay. Next, a ray of light is incident towards a plane mirror at an angle 30 degree with the mirror surface. What will be the angle of reflection? So, since that means angle of incidence, that is 30 degree, and they have asked what will be the angle of reflection. Now here you have to apply the law of reflection. So since the angle of incidence is measured between the incident ray and the normal, so here the angle of incidence is not, so the incident towards the plane mirror at an angle 30 degree. That means if I draw the diagram, this is your 30 degree. Okay. And this is your normal, right? So what is the angle of incidence? This is 60 degree because this is 90 degree, right? So this is the reflection. So incident is not 30 degree. It is 90 degree minus 30 degree, that equals to 60 degree. According to law of reflection, theta I equals to theta R. So hence angle of reflection equals to 60 degree. Okay. Next, a light strikes a reflective plane surface at an angle 54 degree with the surface. Calculate the angle of incidence. So angle of incidence, that is theta I, that will be our 90 degree. 90 degree minus, sorry, this is 54, no? I was supposed to write that, just inversing this thing. So 54 degree, that is 36 degree. Bit 2 here, bit 2. So calculate the angle of reflection. So here the angle of reflection, theta R, that equals to theta I according to the law of reflection. So it will be 36 degree. Then calculate the angle made by the reflected ray and the surface. That means what? If this one is our normal, this is incident ray, this one is reflected ray. So this is our 36 degree and this is also 36 degree. So we have to measure this one. Now in the third case, so angle made by the reflected ray and the surface is 90 degree minus theta R. 90 degree minus theta R. That means this will be our 54 degree. So that is 54 degree. Okay. Question number 4. Calculate the angle made by incident and reflected rays. Here angle made by the incident and reflected ray, that will be our theta I plus of theta R. So theta I plus of theta R, 36 degree plus 36 degree. Sorry, just a minute. So 36 degree plus of 36 degree here. So this will be our 72 degree. This will be our 72 degree. Fine. Next, find the angle alpha. Where is the alpha? This is the alpha. Okay. Alpha made by the system of two mirrors in the figure above, so that in the figure here, so that the incident ray A, this is the incident ray, this is the incident ray A. So this is the incident ray A, and the reflected ray B are parallel. B here reflected ray, this is parallel. So here we first complete the given diagram with the angles of incident and reflection as shown here, and also the level the incident and the reflected rays. For incident ray at A and the reflected ray at B to be parallel, angles here, if it is I and this is I prime, this is I prime, this is R prime, and this is our I, this is our R. So here you have the angle of incidence, here you have this line, so here you have this line, and then this will be the reflected ray. So here we can write down that for incident ray at A and the reflected ray at B to be parallel, angles I plus R, that should be equals to I plus R dash, just a minute, I plus R, this I plus R and I prime plus R prime, this have to be supplementary. That means here parallel lines cut by the transversal. So these are the two parallel lines. So this will be the line which is cutting these two parallel lines. So here you can see that this will be supplementary. So here we can write this thing. I plus R plus I prime plus R prime, that equals to 180 degree. Now by law of refraction, R equals to I and I prime equals to R prime. So we can write down I plus R plus R, that equals to 180 degree. Or we can write down I plus I, that equal to I prime plus I prime, that equal to 180 degree. So in a triangle AOB, so this is your alpha, this is our O, this is our A, and this is our B. So in the triangle that is AOB, we have alpha plus 90 degree minus R plus 90 degree minus I prime, that equals to 180 degree. So alpha equal to R plus I prime or I plus I prime, that equal to 90 degree. Now if alpha is 90 degree, then incident ray at A and the reflected ray at B are parallel. Okay, fine. Now the concave mirrors. Here by reflection of light, let me change this pointer color. By reflection of light, concave mirrors give real and inverted images if the object is beyond the focus and a virtual erect enlarged image if the object has a distance less than the focal length from the pole of mirror. So first thing is this. This is the concave mirror, and whatever the surface you have, the midpoint, this is called pole. Okay, this is called pole. And the line, horizontal line that passes through this pole, this is called principal. This is called principal axis, right? And the center of curvature, this one is your center of curvature. So the total length up to this point, this is the center of curvature. This is the center of curvature. And the focus, this one, and this is the, here actually we are drawing, this is not reflecting surface, only this portion, this is the reflective surface. So if pole is defined as P, so PF, this is the focal length. This is the focal length. And light comes from this, it will incident here, and here you can see that again it will be reflected from the surface. Okay. So this is the concave mirror. So concave mirror, that means there is this type of mirror where you have, this is the reflection surface, and this is not the reflection surface, the opposite side, and this one is the pole. The curvature, the midpoint of this curvature is the pole, and the focus, then center of curvature. So if we assume that, suppose there is a circle, right? There is a circle here, and I am just drawing, this is the, and this one is the length, this one is the mirror. Okay, this one is the mirror. So this is this point is the center of the circle, and this is the center of curvature. Okay, got the point? So this is the mirror. Now up to this much for today. Thank you all. Thank you.